What is going on, peoples? What are you guys up to? Let me just set things up. Alright, I'm loading up Comfy UI. So, what should we work on today? I was thinking of going through some use cases that we could maybe look at. Maybe in painting. Like, I'm really interested in learning how in painting can be done with Comfy UI. Let me just Alright, let me load up Comfy. And then we'll see what we can do. Now this is just a graph I was working on, ignore this. Alright, we have our Comfy. Let's see. It's interesting. Let's actually also check out what Flux is doing in painting.
Today we will see a workflow for painting that is adapted to the Flux Dev model. This workflow allows you to make changes to very small parts of the image and still get quality and a good combination of the change in the original image. This workflow is similar to the workflow I uploaded before and is adapted to SDXL. With two significant differences. The in-paint for SDXL allows us to work with ControlNet, something that really helps the model to understand the environment, perspective, and context. We still don't have when working with the Flux model. On the other hand, Flux's in-paint allows us to work with text, which is a big advantage, something that really helps the model to understand the environment.
Let me just go grab my water. I'm also dealing with cough. Alright. Where were we? Let me just go back a bit.
In the original image. This workflow is similar to the workflow I uploaded before and is adapted to SDXL. With two significant differences. The in-paint for SDXL allows us to work with ControlNet, something that really helps the model to understand the environment, perspective, and context, which we still don't have when working with the Flux model. On the other hand, Flux's in-paint allows us to work with text, which is a big advantage that Flux has over SDXL. You will of course find all the links, including the link to the SDXL in-painting, in the description of the video. Here we have the models, of course, the FlexDev, the Clip, and the VE. Remember that with this model we are limited in the commercial use we can make at work. Here, of course, we have the load image, the image we want to in painting. In this window you also press the right button and simply draw the area you want to change. As you can see, I put it on the negative just to make it easy for me to see, but it's completely up to you. Notice that with this workflow, you can change very small areas, like this label, and still get very good accuracy and quality, even though it's a very small area. In this group of nodes, we simply cut this mask that we drew here and the image according to that mask. This is what we see here. The image after cutting and enlarging is sent to VE and latent noise mask. Let's just understand what's going on here. We have one node that only shows us the sizes. I used it when I built the workflow, but I left it anyway. Here are two mask crop region nodes. It looks a bit strange, and let's understand why they are both here. When you use the mask crop region, one of the data you need to define is the padding, which is the space between the mask and the frame of the image. The padding depends a lot on the size of the mask you drew, and the size of the image in terms of the number of pixels. I use a node with padding 0, the width of the mask I drew in pixels, and I multiply the number by 0.2. In other words, I add a margin of 20% of the width of the mask. You can of course play with this number. And in this case we got that the padding is equal to 16. This is simply to help the model better understand the context of the object we want to receive. From here we cut both the image and the mask. As you can see, I use image crop. It simply takes the width, the height, and the X and Y from this image. And this is the cut we get, according to the same mask we created.
So okay, wait, KG nodes for comfy UI, WAS node, convert mask to image. Okay, I mean, this is new, so I'm just gonna let it wash over me and then we'll try to
And
do
here we
it.
see the mask after its enlargement. An important figure that you should pay attention to is the mask blur, which allows us to blur the mask. Notice that in the amount I set it to 200, which is a lot. From the many attempts I've made, it really helps the differential diffusion to better understand the context, the nearby pixels, and create a comp
So back.
blur the mask.
You just speed it up a
Notice
bit.
that in the amount I set it to 200, which is a lot. From the many attempts I've made, it really helps the differential diffusion to better understand the context, the nearby pixels, and create a complement that is much more harmonious and integrates in a better way with the original image. Here we have the prompt. It seems that our prompt is very complicated and complex, but our prompt is You can see it here in show text, all in all, photo of the word flux on a white jar, high quality detail. If we look for a moment, here we have the basis of the prompt, photo of XXX, YYY, high quality,
Okay.
and if we enlarge it we will see that it has a continuation. With the help of these text find and replace nodes, we replace the XXX with the object we want to add, in our case the word flux. And this text goes in here, and here we do text find and replace the YYY with the context. In this case, white jar. It is important to add the context, so that the model will have a better understanding of the environment of that object. This text goes into Clip's text encode, and all this together with our latent, and the mask goes to the latent space. Here we have the new flux guidance node. If we take a look at the Comfy blog, I will of course put a link to this page. You can see that we have here the flux guidance, which allows us to play with something that is a bit similar to CFG, as we know it. The rest of the things here are quite similar to what we have already seen. There is a seed here that should be set to fixed, of course if you want to check how other things affect the result. Here you see the number of steps, and the denoise is currently at 0.91. You can play with it between 0.8 and 1. From the experiments I did, this is more or less the range that gave me the most interesting results. Of course our model goes through the differential diffusion, which is the reason, as we mentioned before, that our mask with a very high blur. It helps the differential diffusion to understand the context of the new object within the existing pixels in the image. Here we see the picture that VE code gives us. It's the exact same picture. We'll soon understand why we have both. All in all, this group, and this group as well, help us connect everything to the original picture. Here we see the final result.
Happening in flux.
A pretty perfect result for me. The quality of the text doesn't just drop. It's because it's a very, very small area. You can see that the quality is much better. But this is the result after we enlarge the area of the mask, and then we reduce the image back to its original size. This is a very, very small area of the mask we drew, and we return the image to this size. For that, there is the resize here. As you can see, it gets the width and height from the crop mask region, which we saw earlier. And that's why we see a relatively low quality here, because we really reduce the result that will fit into the original image properly. The image composite connects these pixels, after reducing them, exactly to the location, according to the X and Y. If we go up here, we see that we have switch, image and mask. There is image 1 and image 2 here, which are basically the same image, only the masks change. Once I use the initial mask we created to connect the result we got.
That's
This is the
interesting.
result that we choose one switch.
I'm actually more interested in like a workflow that I can in painting on flux and segment anything do. That's interesting. Okay, let's go back to Stable Diffusion Excel.
Means how closely
Actually, let's just do this. Let's pull up something from Scott, Jet Violet, and see what he has. Okay, let's actually check his Laura tutorial.
I've been traveling a bunch, so I'm back now. You can get some more videos out. And today I'm going to talk about something very cool that came out. It allows you to take images and combine them. Kind of like a one-step more, and it's very cool. And there's some really interesting things you can do with it. I think this is one of those tools we're going to be exploring for quite a few months because there's so many ways to adapt it into your workflow. So what we're going to do today is I'm going to show you these two images combined into another image. But we're going to do some other things with it, like we're going to throw a control in there to help guide it. We're going to remove the prompt completely. And there's some different things you can do with this. Again, I'd love to see what you guys create with it. It's just another one of those little creative tools, and we can combine as many images as we want. But we're not using the image, and a lot of them we're using the context of them. So it's kind of like image as a prompt. So this is called an image prompt adapter, and you may have seen videos or heard about it, or IP adapters has been shortened, and that's what we're going to cover. Now, again, in my way of doing things, I like to do it a little more creatively. So we're going to walk through the basics first, but then we'll go off the deep end and take the red pill. All right, we're going to start out pretty easy today. We're just going to look at the default. So we're going to click default, and there you go. I'm going to spread this out a little bit because it's kind of like everything's crowded. During the demos, things like this, I like to see all the nodes are spaced out. Even though it's a little ugly, I think it's easier to follow if you can actually see the lines instead of having them tucked behind things. All right, there we go. That looks pretty good. All right, let's talk about the nodes we're going to need for today. If you go on Manager here, click on Install Custom Nodes. I have mine set to install here so you can see it. What we're going to have for today is this comfy UI. Plus, right here, you're going to need that. All right, there we go. That looks pretty good. All right, let's talk about the nodes we're going to need for today. If you go on Manager here, click on Install Custom Nodes. I have mine set to install here so you can see it. What we're going to have for today is the UI IP Adapter Plus.
Let's check if we have this. UI IP adapter. Yep, alright, I have this. It's good to know.
Right here, you're going to need that one. And we're actually going to also use this comfy UI SDX. Empty latent because this saves us some time and I want to introduce it to you.
Comfy UI SDXL empty latent. That's another one we want to check. Comfy UI empty latent. Alright, I also have that one. Good. Good job, me.
And then the other one we use is actually as well because this thing can fly.
ControlNet auxiliary preprocessors. I think I already have this one, but let's check. ControlNet auxiliary. Yep, I have that as well. So once again, good job, me.
Out of whack pretty easily, and we want to control it. This is a great way to do so. This technique that I'm going to show you here, I think, has so much potential in really unique ways to approach just putting in your models. So I'm going to show you a few of the things that I've discovered so far, and I'd love to hear if you come up with some. I think this is one of those like groundbreaking things. Now, initially, this is going to seem like revision, and we talked about revision earlier, a technique where you can kind of combine images, and it originally, or initially, I should say, but it's actually more kind of like a one-image LoRa. So that's kind of how I'm talking about it or looking at it. So let's set this all up. First thing we're going to do is we're going to erase our prompt completely. We're going to use this, and we are going to use SDXL, but we're not going to use the SDXL clip here. We're just going to use this just for simplicity's sake. But again, when you're working on your bigger models, your bigger projects, use all the tools that you have available, but we're not really kind of featuring a bunch of that stuff today, so I don't want to overcomplicate this diagram. But I do want to complicate it a little bit, so let's go to that. And we're going to type in the word latent here. I can spell it, and it's today, so I don't want to overcomplicate. But again, when you're working on your bigger models, your bigger projects, use all the tools that you have available, but we're not really kind of featuring a bunch of that stuff today, so I don't want to overcomplicate this diagram. But I do want to complicate it a little bit, so let's go to that, and we're going to type in the word latent here. I can spell it, and it's near the bottom here. Where's SDXL empty latent image? And what this is going to do is it's going to give us all of the resolutions that are safe for SDXL. And what I mean by that is SDXL works with these resolutions and square, which of course, our first models were square only. This has a lot more capability, especially if you work in the ones that it's safe for. So use these if you want the best possible results. So we're going to put that right in the latent there and be done with it. And I don't like my lines to, wish my lines didn't cross here, but they do. But I don't want to look, I didn't want that to line up like that. That's the kind of thing that can cause problems. So I at least want them to cross violently. If they're going to cross, we'll just do that. In fact, we'll just go nuts here. Yeah, that looks terrible. Let's keep it like that. Yeah, this is the anti-OCD today. Right? What are we here for? All right, so what we're going to do is we want to actually inject something into the model stream here. And what we're going to inject is a pretty interesting thing. It's going to take an image and allow it to work with the prompt, and it's going to combine the image and the prompt as it goes through its step-by-step process. So this is a little bit different than revision, where revision kind of used the soul of the image. This is going to use the clip model to help us figure out what's in the image as well as the image itself. So to do that, let's go ahead and load it in. So double-click and type in IPA, like beer, and IPA apply. We're going to grab that and bring that in. And again, like I said, it fits right in the middle of the model workflow, so just throw it right in there, right in the middle there. And it's happening. We'll minimize this because we don't need to keep looking at that. All right, and we'll minimize the negative 2 because we're not going to use that either. We will put a positive in here later, but for now we're not going. Okay, so what do we do with this thing? It's pretty simple. As I said, it's going to take an image and then push it into the path of the model here, and we're going to get some interesting things out the other side. So let's see what we need here. IP adapter. If you pull that out, you only have one option other than reroute here. We'll pull that up here. And you're going to see there's a bunch of models that come with it, or at least on the link I'll put below for the Git. And you can see them here. We have some that say face in them. Those are obviously 4 faces. And there's not one for SDXL face at this point. Now, face would be if you're trying to make an image that looks very similar to someone else. Now, if you don't need the face to be exact, and if it's close enough, then don't worry about using the face model, which is what I'm going to do. I'm not going to use the face model today because these are not people that I know. They're just made up. So the face and keeping that same face throughout this is not my goal. Now, I'm using SDXL here. So you'll notice that there's a few options here. We have a BITH, and BITH is the one with more tokens, so it's larger. And if we use this, we must use the clip vision model that also has VITH in the name. Now, you can use this same clip vision with other ones that don't have VITH, but just realize if you get an error, it's because you're probably using that model here and not this one. So this is the one I grabbed here off of Hugging Face, so that's the one we're going to stick with, and it's a pretty standard one. So you should already have it on your machine. If you don't, well, now you'll go grab it. All right, what we're going to do here now, we're going to load in an image. So I'm just going to right-click, Add Node, Image, and we're going to load an image. And I'm going to change this one. I'm going to load this one in here. I've used this one before, and I really like this. This image is amazing to me. Like, there's so much going on that's fantastic. So I want to use this one. I'm just going to drag it in here to the image. Now, right now, the weight is set to 1. So we're going to get something that's kind of similar if we just run the prompt through here. Let's just do that. And I'm not going to change. Oh, yeah, change this. I always put this up to like 30 or 35. And we'll keep this at Euler and normal. There's no reason to change that. But we'll change this to fixed, just so we stop mixing our variables around. And whenever you're testing our theory on how things work, make sure you change these to fixed, so you can actually understand the differences when you're fiddling numbers, what's going on. Otherwise, you're getting a random seed every time. And it's really hard to track down what's moving. So let's just queue this and see what happens. And I totally forgot to change my model. There we go. We're going to use SDXL base. All right, and you see we have a pretty similar image, which is what we would expect. Because we did nothing except, hey, this image is worth 100% of your goal. Just go ahead and get an image that looks all like it. And you know what? It did it. So congratulations. You've done nothing. All right, so now let's improve it. And here, this is where it gets really cool. Let's take this image and let's load in another image. Let's load in this image here. And I did a bunch of sci-fi stuff. We'll be doing a bunch of this. I love sci-fi stuff, so it's always going to happen. But what I want to do is I want to use these images. So there's only one input for image here. We need to batch these together. It's simple. Just drag this out and look for image batch. Put them together, and now they are one. And they go open here. Now, this is not the same thing as merging of images, meaning they're not overlaid on top of each other. There's no blending mode or anything like that. They're simply two completely different universes for what we're doing here. In fact, they're not even the same shape. So what this is going to do is it's going to look at not only the image itself, but what's in the image. And if you're doing this, don't load the same girl 8 times, for example, unless she's in a different scene and you want the aspects of that scene. For example, in this scene, we really don't see anything that's sci-fi. There's some steampunk hat here, but nothing is the smooth type of hard modeling here we find on this or the thrilling headgear or the outfit. So these should be of equal weight. Again, we have not added a prompt at all at this point. And we're still sitting at 1 and no noise. Now, noise means if we don't have any noise, it's going to pass in basically a black image and say, don't worry about the noise part. If we add noise, we'll get a little bit more detail and a little bit more interest in the image. So we can do that. Well, let's do it without that first. So you can see we've only changed one variable, and that is including of this image here. Let's queue it up. Okay, and now I came back, and you can kind of see that we're getting a combination of the steampunk as well as the sci-fi thrilling headgear and some of the more hard surface modeling here. So it's kind of combining the spirit of, let's add one more. If we add this, we're going to need another batch image here, and this batch image is going to feed into this one. We're basically daisy-chaining them together. Let me do that a little smarter way. These two over with this one. There. That probably makes a lot more sense. And then that's what we're getting to. I do want to move these closer, though, so we can actually see the spirit of them. But just so you know how those are connected, they're all daisy-chained together. What are we going to look for this last one? Just something that doesn't have a person in it. Or for something like flowers. Here, let's use this one. I really like that one, too. All right, so we got 3 completely different images here. I think this was actually even done in Midjourney, as I recall. I can't remember, a little while ago. So, again, all 3 of these, doesn't matter the order they're put in, but they're all going to contribute, and they obviously have nothing in common, although the color palette of this one and the color palette of this one are similar, and we'll see what's happening. Now, if you got this already, hold your horses, because we're going to get here in a second. And let's see what this looks like. By the way, every time you add another image in here, you are increasing the memory requirement for this, so don't go overboard. Add them again if they're unique and present something to the image that's unique and isn't overrepresented. So it's going to say what the difference is between these and include those items. And there we go. So we have some flowers, we have thrilling headgear. Yeah, it's all working well. But what I really love is I love this pose, and I want this pose. Now, there's a couple of different ways to do that, but the easiest way is going to be using control net. So let's go ahead and add some control net. So we're just typing control net, and we have control net apply. We'll just use that as our point of departure here. So this obviously fits over here in the conditioning between the prompt we're not using and here. And we're not going to put one in the negative side. That doesn't really going to matter here. This means that the control net is more important. So let's do the control net here. Let's roll that out. Control net loader, and I want to load in the canny one. We'll load in the canny for the SDXL. Remember, the different control nets are required for the different models because they're different shapes. And then the image here, we need to pre-process whatever one we want to use. So I'll use this one here. And we'll grab the canny edge preprocessor, put this in here, and drag it in. So this will the edges basically. And let's set this to 1024 because we are using SDXL. Now, remember that we're not dragging in the combination of all three of these, because that canny edge is going to look totally bizarre. Because it's going to be all three of these overlaid on top of each other, and that's not what we want. So we're just going to do this. And for strength, I'll put it down to 70%, so it's not perfect, but it should be this pose. Let's try it again. Again, we are using the locked seed, so we aren't going to have a totally different image. But now it's going to take that same image and lock it in with that control. There we go. So we have now our canny with the interesting pieces that we've added from these other ones. So that's working pretty well. I'm pretty happy with it. Yeah. All right, so what else do we do with this? Well, first of all, we're not even using the prompt, and we're not using the noise. So let's do that. Let's add a prompt here. Let's use a female astronaut, and we want to drop the weight scale to chance to play, because right now it's not. We'll put that down to, say, 70%. And let's run that without the noise first, so you can kind of get the idea of what's going on here. And there we go. So it's a little bit more interesting. It's cleaned up a little bit. If we were doing this a little more seriously, in the canny part, for example, we'd stop near the end to prevent a lot of those lines from leaking through. But this is coming together rather nicely. So it's adding some of the additional sci-fi detail from the last one. We can give the prompt more information here, and then give it more weight if we'd like. Let's add some noise in here. Let's say 30% noise somewhere. And run it one more time. In fact, I'm just going to copy this over and put this up this way. So we have a before and after. I think it's going to be an easy way to look at it. Oh. Yeah, use Control B, which is bypass. And that will allow it to continue on without this, and we can come back to it in a second. So you can see that introduction of noise allowed it to have a little bit more freedom as it's interpreting the image. Again, still using Control Net to hold this pose in his face, and the hat, frankly, but it's using these styles here. So if we start to eliminate these, we'll see that there's a big difference. For example, if we use this one as the canny control and get rid of this image completely, and then rearrange our family here. Oops. Basically, I'm eliminating one of the images. We would just have these two, and we're using canny on this one. Let's try again. Oh, we gotta bypass that again. Actually, I'm just going to get rid of this since they're not side by side anymore. And there we go. We have a nice combination of these two images in there, along with the prompt driving the sci-fi theme. Now, the part of this that I think is more interesting, I mean, this is all good, and I really like this, but where I want to use this, so I'm going to get rid of these, and this is kind of how I'm using it, to keep just this, and I don't want the canny. We're not going to use any control net for this, actually. sorry, you control net fans are like, what? It's fine. We're just going to use this image as it is, but what I'm going to do is I'm going to put a texture in, and I'm going to run it at a really low weight, not really low, let's say 20%, with some noise is fine. And we're going to use the same thing, but I'm going to let it render whatever it's going to render. So the sci-fi theme we saw earlier with the same seed will show up, but it's going to introduce this, which will help drive the scene. So this will change things. I did a video, months ago, on how to find scenes in textures, and this is really kind of coming to fruition here and working pretty well here. Let's see what we get. There we go. So you can see that it's using this color scheme here, which I really like. Well, I think this is a fantastic tool, and there's so much we can do with it. So I would love to see what you're going to do. Again, this is one of those things I think for months we're going to be playing with it and adding it to workflows, and I'm going to toss it into my workflows, even if it's just at a low weight, because it allows me to use some of those handmade textures that I made before and bring them in. It's really cool.
Okay, that's a really good demo. Actually, I think I'm going to switch focus for a bit, because I've been meaning to go back and and I feel like I have done this. I'm just checking. Okay, I don't think I've done this. Let's see. Fast AI, I'm going through. I'm going through their stuff, because my deal is to just go through all of these right here and eventually just finish them. So every day I'm going to be dedicating, let's say, about half an hour to go through them. So let's get to it. And let me just get my notes, my iPad, so I can take notes. I am very tired right now. I'm going to power through this. Okay. Alright. We've got enough battery, which is always a good sign. So let me just put my phone on charge. Just give me a minute, I'm just searching for something. Alright, I found it. Alright, let's see. So let's take a look at this.
Link here to a notebook I created to most of the work done by Ross Whiteman, where we try to improve this by finding better architecture.
Just give me a second. Let me just go to my notebook to see where did I actually stop. Oh no, I think I was even before this. I'm actually jumping ahead in lessons, I think. I think I was right here, actually. Yeah, I was
So
right here.
there's a dog, a cat, and a donut.
Okay, let's just do this.
You can go ahead and create a radio interface. For classify image with our dog image, we get back a dictionary of a dog. Yes, definitely cat, definitely not. So now we've got all that, we can go ahead and create a radio interface. So radio interface is something where we say, well, what function do you call to get the output? What is the input? In this case, we say, oh, the input is an image. And so to check out the radio docs, it can be all kinds of things like a webcam picture or
I'm just starting this over.
all kinds of things.
I'm sorry, I have forgotten everything.
Sorry about the lack of direction. I'm actually really pumped about this lesson. It feels like going back to what things were like in the very early days because we're doing like some really new, really cool stuff, which the stuff that hasn't really been in courses like this before. So I'm super excited. So thanks a lot for coming back after lesson 1, and I hope it's worth you coming back. I think you're going to love it. I'm really excited about this. Now remember that the course goes with the book, so be sure that you're following along the book. We're covering similar things with directions, so like read the book as well. And remember the book is entirely available free as well. You can go to the repo, see notebooks, or through course.fast.ai. You can read it there, for example, through Codelab.
Good sketch.
And also remember that the book talks about a lot of stuff that we did cover in the course, like stuff I find interesting about history of neural networks, some of which has some really interesting personal stories actually, as you'll read here. And at the end of each chapter there is a quiz. And remember, it's not a bad idea before you watch the video to read the quiz, so if you want to read the chapter 2 quiz, and then come back, that's not a bad idea. And then make sure that you can do the quiz after you watch the video and then read chapter 2 of the book. Something I didn't mention last week is also a very cool thing that Radek mentioned last week. It's written called AIquizzes.com, which is a site specifically for quizzes about book. And it actually uses repetitive-based learning techniques to make sure that you never forget. So do check out AIquizzes.com. It's all brand new questions. They're different to the ones in the book. And they're really nicely curated and put together. So check out AIquizzes.com as well. Remember, as well as course.fast.ai, there's also forums.fast.ai. So course.fast.ai is where you want to go to get links to all the notebooks and Kaggle stuff and all that stuff. You'll also find on forums.fast.ai, every lesson has an official topic, with all the information you'll need. Generally, there'll be a bit more info on the forums. We try to keep the course lean, and the forums are a bit more detailed. So if you find, in this case, we want to look at lesson 2 official topic, there's also one official topic so far. So from lesson 1 official topic, already, after just a few days since I recorded it, we haven't even launched the course, so just doing it live, there's already a lot of replies, and that can get pretty overwhelming. So be aware that there's a button at the bottom of my post that says summarize the topic. And if you hit that, then you'll just see the most upvoted replies, and that's a really good way to just make sure that you hit on the main stuff. So there's a button, and if it looks like I hit it, you'll just get the upvoted stuff from fast AI legends like Sanyam and Nish. So hopefully you'll find that a useful way to use the word. So one of the cool things about this week is I, as promised, put up the Show Us What You've Made post, and already a lot of people have posted. I took a screenshot a few days ago, it's way above 59 replies already, if I remember correctly. I had a lot of trouble deciding which ones to share, because they're all so good. So I've actually decided kind of, went the easy route, and I just picked the first. So I'm going to show you the first ones that were posted. They're also good. So the very first one we posted is a damaged car classifier. So that worked out pretty well, it looks like. And I really liked what Matt, the creator, said about this is that, wow, it's getting uncomfortable running code that I don't really understand yet, but I'm just doing it. And so I'm like, yeah, good on Matt, we're just doing it. That's the way to get started. It's all going to make sense, don't worry. Very nice to see that the next one posted was actually a blog post in Fast Page. It's very nice to see they're describing some stuff, some experiments that they ran over the week, and what did they find? Next one was the amazing beard detector, which I understand correctly was mainly because it's very easy to convert beard. One out of 2, and this is doing a very good job of finding genuine beards. So very nice. And this one, again, it's a whole in production web app to classify food, which kind of like extra credit. Apparently we're up to 80 replies now in that thread. Thanks, very cool. Obviously, so this was actually created by Sudash, who's been doing the courses for a few years now, I believe. And so, one day you too might be able to create your own web app. And when I say one day, more specifically, I'm going to show you how to do this right now. So it's actually quite a lucky coincidence that Sudash put this up there, because it's exactly the topic we're going to pick today. So how do we go about putting a model in production? Step one is well, you could have done step one. Right? Step one is step 1, 2, 3, 4. It's figure out what problem we want to solve, figure out how to find data for it, gather some data, and so forth. So what's kind of the first step after you've got data? And if you go to chapter 2 of the book, which I'm going to go ahead and look at.
Just change one thing on Twitch.
Up now. So here is the book. You can open it in Colab directly from the course, or you find it on your computer, or whatever, you can go there. So remember, we'll run you through exactly how to run these notebooks. And so you can see chapter 2 is production, and so here is chapter 2. All right, and so remember, we hit Shift Enter to run cells. Okay.
Wait, so how do you get Fastbook?
If you go to chapter 2 of the book, which I'm going to go ahead and open up now. So here is the book. You can open it in Colab directly from the course, or you find it on your computer, or whatever, you can go there.
Fast AI book. Fast AI. Okay. There it is. If I'm right. Okay, this is good. Let me just drop it in here to rename it. Collab notebooks. I gotta go through these as well, which is introduction to philosophy, etc. But for now, let's jump back to deployment.
There, so remember, course stuff today, I will run you through exactly how to run these notebooks. And so you can see chapter 2 is all about putting stuff in production. And so here is chapter 2. All right, and so remember, we hit Enter to run cells. Okay. And so we're going to go to the part of the book where we start cleaning data. So I click on Navigate, and data. There we are. So we could do a quick bit of revision first. And by the way, I want to mention, a lot of people ask me what are the little tricks I use to get around Jupyter Notebook so quickly and easily. One of the really nice ones is Navigate, and English actually doesn't appear by default. So if you install something called Jupyter Notebook Extensions, and so you just pip install them, follow the instructions. And then restart Jupyter. Obviously, Colab already has table contents, by the way, so just if you're using something local, for example, then you'll see here this MD extensions thing here. And table content 2, which is can navigation. Is this one here, headings. And that's the one which gives me these nice little things here to close, open up. And actually, that's not even the best part. The best part for me is if I hit right arrow, it goes to the end of the section, and if I hit left arrow, it goes to the start of the section. So it's like if I want to move around sections, just press up, left, down, right, very handy. And if you hit left again, when you hear it, close it up, hit right again, here, open it up. So that's what it is. Anyway, a couple of really handy things. And we'll be talking a lot more about getting notebooks set up today. Okay, so one thing you'll notice is in the book, we use Bing API to search images. I've just gone ahead and replaced Bing with DDG because Bing API requires getting an SSID, which honestly is like the hardest thing figuring out the Bing Azure website and that sort of DDG doesn't. So it's basically exactly the same, and you can, I'll share this notebook as well on the course website forum, but all I've basically done is I've thing with DDG, got it with it. So then, just like we did last week, we searched for things, and so in the book, we did a bear detector, because at the time I wrote it, my bear partner was very interested in me helping identify dead bears, and I certainly didn't want to accidentally cuddling a grizzly bear. So we show here how we can search grizzly bears just last week. Some deliveries to grizzly bears, like teddy bears, last week. Failed. And one thing a few people asked on the forum is how do I find out more information about basically any Python or FastAI or PyTorch thing. There's a few tips here in the book. One is that if you put a double question mark and it's any function name, you'll actually get the full source code for it. And by the same token, you put a you'll get a brief information. If you've got any dev installed, if you need, then you type doc, and that'll give you, that's most importantly, a link straight to documentation. Where you can find out more information. Generally, there'll be examples as well. And also a link to the source code if you want to. Let's do that with control. Okay. Link to the source code, and that way you can jump around. Notice that in GitHub and source code, you can click on things and then jump to the definition. So it's kind of a nice way of skipping around to understand exactly what's going on. Okay, so lots of great ways to get help. But what I promised you is that we're going to now clean the data. So I'm going to tell you something you might find really surprising. Before you clean data, you train a model. Now I know that's going to sound really backwards to what you've probably heard 1,000 times, which is the first you clean your data and then you train your model. But I'm going to show you something really amazing. First, we're going to train a model. And you'll see why in a moment. So to train a model, just like before, we use data block to grab our data loaders. There's lots of information in your book about what's going on here. There we go. And so then we can call show back to see them as per usual. There's a little sidebar here in the book I quickly mentioned, which is about different ways we can resize. I think we briefly mentioned it last week. We can squish. Last week we used a string. We used a string or this kind of non-like thing we have. You can end up with very thin bears, right? So this is the real size of the shape of the bear. Here it becomes thin, but you can see now we've got all of this cuts. Yeah, bear cuts. So it's squished it to make sure we see the whole picture. Same one here. This one's out of the picture. We squished this guy down. It's really thin. We can see the whole thing. So that's squishy. Whereas this one here is cropped. It's cropped out to the center of the image, so we get a better aspect ratio, we lose stuff. This is so we can get square images. And the other approach is we can use pad. And so you can pad various things. You can pad zeros, which is black. You can see here now we've got the whole image and the red aspect ratio. So that's another way to do it. And different situations, it'll result in different quality models. You can try them all. It doesn't normally make too big a difference, so I wouldn't worry about it too much. I think one that is very is resize crop. So instead of saying resize, we can say random resize crop. And if we do that, you'll see we get a different bit of an image every time. So during the week this week, somebody asked on the forum, I'm trying to, it's a really interesting idea, it turned out worked slightly, was they wanted to recognize pictures of French and German texts. So obviously this is not the way you do that, but it's a really big experiment, another experiment. So they had really big scans of documents. And they wanted to figure out whether it's French or German by looking at images. And they said, pictures are too big, what should I do? And they said, use random resize crop, and that way you have different bits of the image. And this is very nice, because you can run lots and lots of epochs and get slightly different pictures each time. So this is a very quick tip. And this idea of getting different pictures each time from the same image is called data augmentation. And again, I'm not going to go into too much detail about data augmentation, because it's in the book, but I'll just quickly point out here that if you use this thing called aug transforms, so augmentation transforms, and here I have multiplied by 2, so I made it super big so you can see it more easily. You can see that these teddies are getting turned, warped, recolored, saturated, stuff make every picture. And generally speaking, if you're training for more than about 5 or 10 epochs, which you're probably going to do most of the time, and that's sort of a super easy problem to solve, you'll probably want to use random resize crop and these aug transforms. Don't put more fields too, to leave that empty. I'm just putting it there so you can see them more clearly. So I've got an interesting question here from Alex in our audience, which is this copying the image multiple times, doing something like this, or something like this? And the answer is no, we're not copying the image. Each epoch, every image gets written. And what happens here is though, is kind of in memory, in RAM, the image is being warped, right? We're cropping it and recoloring it and so forth. So it's a real-time process that's happening during model training. So there's no copies being stored on the computer, but effectively it's almost like there's infinitely slightly different copies because that's what the model ends up saying. So I hope that makes sense. Balance. That's very nice. Okay, so we're going to use random research prop, we're going to use augmentation transforms, so that we get the data loads from that, and then we go ahead and train our model. It takes about a minute. In this case, we only did 4 epochs of fine-tuning, and we'll talk about why there's 5 here later in the course, but 4 main epochs fine-tuning. So we probably didn't really need random research prop in all transforms, because there's so few epochs. You know, we want to run more epochs. This is a good approach. Under 3% error, that's good. Okay, so remember I said we're going to train the model before we clean. Okay, so let's go ahead and train it. So while that's training, it's running on my laptop, which only has a 4GB GPU, pretty basic, it's enough to get started. While that's training, we'll take a look at the next one. So the first thing we're going to look at is the confusion matrix. And the confusion matrix is something that only is meaningful when your labels are categories, right? And what it says is what category errors are you making? And so this is showing that the model that we've got at this point, there was there, and it thought it was black there. And there was 2 times when it was actually black there, and there was no times it got Teddy's wrong. Which makes sense, right? Teddy's a bit of a focus. In a lot of situations, when you look at this, it'll kind of give you a real sense like, okay, what are the hard ones? Right? So for example, if you use the text data set that we quite often play with in the book and course, this classification matrix for different degrees of text, it'll really shows you which ones are difficult to identify, and I've actually gone in like read Wikipedia pages and kept reading reports about how to identify these particular facts because they're so difficult and experts find it difficult. And one of the things I've learned from doing the course actually is black bears and grizzly bears are much harder to pick apart than I had realized. So I'm going to try. But I'll show you the really interesting thing we do with this model is that now we've created this classification interpretation object we use for confusion metrics. We can say plot top losses. We can say plot top losses. And this is very interesting. What it does is it tells us the places where the loss is the highest. Now, if you remember from the last lesson, the loss is that measurement of how good our model is that we take after each time we run through an item data. A loss will be bad if we predict wrongly and we're very confident about that prediction. So here's an example where we predicted, here's what here, prediction actual loss probability, where we predicted grizzly and it's actually a black. And we were 96% sure, our model was, that it's grizzly. Now, I don't know enough about bears to know whether the model made a mistake or whether this actually is a picture of a grizzly bear. So an expert will obviously go back and check this out. Right? Now, notice a couple here, it's got grizzly, teddy, they're actually correct. Right? So why is this loss bad when it's correct? And the reason is because it wasn't very confident. It was only 66% confident. Right? So here's teddy, it's only 72% confident. Right? So you can have a bad loss either by being wrong and confident or being right. Now, the reason that's really helpful is that now we can use something called the image classifier cleaner to clean up the ones that are wrongly labeled in our data set. So when we use the image classifier cleaner, it actually runs our model. That's why we pass it. Right? And I mentioned that I don't know much about black bears and grizzly bears, but I do know a lot about teddy bears. So I'll pick teddy bears. And if I click teddy bears, now showing me all the things in the training set, training valid, that were marked as teddy bears. And here's what's really important. They're ordered by loss, so they're ordered by confidence, right? So I can scroll through just the first few and check they're correct, right? And oh, here's a mistake, right? So when I find one that was wrongly gathered, I can either put it in the wrong category, I can choose the correct category, or if it shouldn't be there at all, I can delete. So here I'll go ahead and click delete. Right. So you can see some reasons some of these are hard. Like, for example, here's 2 teddies. It's just, I guess, confusing because it doesn't see that often. This one here is a bit weird looking. Looks almost like a wombat. This is an awful lot of teddies. This one maybe is a bit hard to see background, but these otherwise they're fine. Fine. So we just look through the first few. And if you don't see any problems in the first few, you're probably fine. So that's cleaned up our training set. That's cleaned up our validation set as well. So here's that one I had trouble with. I don't know why I had trouble with that one, but so be it. And we'll have a quick scroll through. Okay, I'm not really sure that's there. So I'm just going to go ahead and delete it. It's telling you something. You know, it's a problem. Okay, that's not a teddy either. So you see the idea, right? So after we've done that, what that does is the cleaner has now stored a list of ones that we changed and a list of ones we deleted. So we can now go ahead and run the cell. And so that's going to go through a list of all the indexes that we said delete, and it will delete those files. And it'll go through all the ones we said change, and it will move them to the new folder. There we go, done. So this is like not just something in image box. It's actually a really powerful technique that almost nobody knows about and uses, which is before you start data cleaning, always build a model to find out what things are difficult to recognize in the data and to find the
That's a very good
help
point.
find data problems. And then as you see them, you're going to say, okay, I see the kinds of problems we're having, and you might find better ways to gather the next data set, or you might find ways to kind of automate some of the cleaning, and so forth.
That's a very good point, actually, that before you start training the model, before you start cleaning before you start cleaning data, you're just train a model and see which categories it's having issues with. Okay.
Okay, so that is data training. Since I only have 4 GB GPU, it's very important for me to close the poll, because that will free up memory. So it's important to know, on your computer, your normal RAM doesn't really get filled up, because if you use up too much RAM, what will happen is that instead your computer will start swapping. So basically save that RAM onto the hard disk to use it later. GPUs can't swap. GPUs, when they run out of RAM, that's it, you're done. So you need to make sure that you close any notebooks that are using the GPU that you're not using, and really only use one thing at a time on the GPU, otherwise you'll almost certainly run out of memory. So we've got the first few reds starting to look here, so remember to ask, and in terms of the yellows, it's important to know, as you watch the video, I'm not asking you to run all this code, okay? The idea is kind of watch it, and then go back and pause, as you go along, or you just stop, try. The approach I really like, and a lot of students really like for watching these videos, is to actually watch the entire thing without touching the keyboard to get a sense of what the video is about, and then go back to the start and watch it again and follow along. That way, at every point, you know what it is you're doing, you know what's going to happen next. That can actually save you some time. It's a bit of an unusual way, because obviously, like real life lectures, you can't do that. Rewind the professor and get them to say it again, but it's a good way to do it. So now that we've cleaned our data, how are we going to put it into production? Well, in the book we use something called Twilight, and it's pretty good, but it's actually something that I think most of you are probably going to find a lot more useful nowadays. There's something called hugging face spaces, and there's a couple of things you can use with that. We're going to look for radio today, and there is a chapter about this in the book, but that doesn't matter, because Shanice Abraham, who's actually one of the AAs in the course, has written a fantastic blog post about really everything we're going to cover today. So there's a link to that from the forum and the course page. So this is like the equivalent to a chapter of the book, if you like. And I would be remiss if I didn't stop for a moment and call out to Nish in a big way. 2 reasons. The first is he is one of the most helpful people in the fast AI community. He's been around quite a few years, incredibly tenacious, thoughtful, and patient. And also because I have this fantastic picture of him a few years ago with Conan, when he was a famous child prodigy. So now you know what happens to famous child prodigies when they grow up. They became even more famous fast AI community members and deep learning experts. So you definitely check out this video of him telling jokes to Conan. I think he's still only 18 actually. This is probably not that many years ago. So thank you very much for all your help in the community. That picture of a 9-year-old. Okay, now the thing is, for doing radio and hugging face spaces as well, it's easy enough to start. Okay, we start over here on the hugging face space page, we can link to more in course, and we're going to put a model in production where we're going to take the model we trained, and we're going to basically copy it to this hugging face spaces server and write a user interface for it. So okay, so we can just go ahead and say, all right, so the whole thing's free. Basically, everything I'm showing you in this entire course, you can do for free. That's the good news. Okay, so name, minimal. I always use the Apache license because people can use your work really easily. But don't have to worry about it. So there's a few different products you can use with it. We can use radio for free. You can make it public and then you can share it, which is always a good idea when you're a student, particularly to really be building up that portfolio. Okay, so we're done. We've created a space. Now, what do we do next? Well, now most software developers will be very familiar with Git. Some data scientists might not be. And so Git's a very, very useful tool. I'm not going to talk about it in detail, but let's kind of quickly learn about how to use it, right? Now, Git, you can use it through something called GitHub Desktop, which is actually pretty great. And even people who use Git through the console should probably be considering using GitHub Desktop as well, because some things are much faster and easier than it. In fact, I was talking to my friend Ham all day, and I was like, oh, how do you do this 2 things by mistake? What do you use to reverse? GitHub. I thought he had some fancy console man. He's like, oh, you should use GitHub Desktop. You can just click on it. Oh, that's a great idea. So that's useful. But most of the time, we do use Git from the console in terminal. If you're a Linux user or a Mac user, you've already got a terminal, very straightforward, no worries. If you're a Windows user, I've got good news. Nowadays, Windows has a drift terminal. It's called Windows Terminal. You get it from the Microsoft Store. So in fact, every time you see me using a terminal, I'm actually using that Windows terminal. Works very well. God knows why I wanted to put all these ridiculous colors. There you go. Now, what do you want to be running inside your terminal? Obviously, if you're in Linux or Mac, you've already got a shell set up. In Windows, you almost certainly want to use Ubuntu. So Windows, believe it or not, can actually run a full Linux environment. To do it is typing a single line, which is this. So go to just Google for WSL install, run PowerShell administrator, paste that command, wait about 5 minutes, reboot, you're done. You now have a complete Linux environment. Now, one of the reasons I'm mentioning this is I'm going to show you how to do stuff on your own machine now. And so this is like going to a bit of an extra level of geekery, which some data scientists may be less familiar with. So, don't worry about the terminal. I think you're going to find it really helpful. And much less scary than you expect. And particularly say, like for me, I choose to use Windows, and that's because I get Windows GUI apps, and I can draw on my screen, do presentations, and I have a complete Linux environment as well. And that Linux environment uses my GPU and everything. So for me, my first choice is to use Windows. My second choice, not very much, I don't really use Linux. Mac is a little bit harder, but it's still usable. So some things are a little bit trickier on Mac, but you should be fine. Okay, so whatever you've got, at this point you've now got a terminal available. And so in your terminal, one of the really nice things about using terminals is you don't have to follow lots of instructions about click here. You just copy and paste this. So you just copy this, you go to your terminal, and you paste it in, and you run it. And after you do that, you'll find that you've now got a directory. And so that new directory initially is empty, and they tell you, okay, go ahead and create a file with this in it. Okay, so how do you create a file with that in it when we're in here in our Linux environment, on Windows or in terminal or Mac, whatever? Well, all you do in Windows, you just type explorer.exe dot, it'll open up Explorer here, or better still, on either Mac or Linux or Windows. So regardless of what type of computer you're on, you just type code dot, and it will pop up Visual Studio Code and open up your folder. And so then you can just go ahead and if you haven't used VS Code before, it's really well worth taking a few minutes to read some tutorials. It's a really great IDE. And so you go ahead and create an app.py file, like they tell you to, app.py file, containing what they told you to put in it. Here it is here. All right, we're nearly there. So you can now go ahead and save that, and then you need to commit it to radio. To Hugging Face Spaces. So one really easy way is just in Visual Studio itself, you can just click here, and that'll give you a type a message, and you hit tick, and it'll send it off to Hugging Face Spaces for you. So once you've done that, you can then go back to the exact same website you were before, Hugging Face Spaces, .gho minimal, and what you'll find now is that it'll take about a minute to build your website, and the website it's building is going to have a radio interface with a text input, a text output, and it's going to run a function called greet on the input, and my function called greet will return hello name. So that's what it's going to do. No, there it goes. Let's try it. We'll say hello to Nish. I'm not always remembering how to spell his name. I think it's like that. And there you go. So you can see it's put the output for our input. So it's not a very exciting app, but we now have, to be fair, an app running in production. Okay? Now, I told you we'd have a deep learning model in production, so now we have to take the next step, which is turn this into a deep learning model. Alright, so first we're going to need a deep learning model, and there's a few different ways we can get ourselves a deep learning model, but basically we're going to have to train one. So I've got a couple of examples. I've got a Kaggle example and a Colab example. Maybe I'll quickly show you both. They're going to do the same thing. And I'm just going to create a over a task file.
Okay, there we go. That's it for today. I gotta do some work and head to sleep soon, so this is it for me tonight. I'll be back tomorrow, basically the same time, 9:30 p.m. Eastern. Make sure to follow me, and I'll see you next